Hello, in this tutorial, I wanted to show you how to read a data file in MATLAB and how to use polyfit. This is for part 3 of your current assignment. Moments ago, I emailed you the data file. I've tried to upload it on Owlspace through assignment 5 as an add-on item, but that doesn't seem to work, at least for me. But here is the data file, okay? And this is how it looks. Okay, so it's a bunch of x values and the corresponding y values. In fact, this is a force distance curve for a computer simulation I did. So what you do is you download this data file from your email and put it in a directory where MATLAB can find it. So I have put it in the current folder, which is the typical MATLAB folder, and have put the file here as force.dat. All you need to do to load this file is to simply say some s or some variable you want to name, let's call it data variable, equals load the name of the file, single parenthesis, and what you have to say, because this is a direct text file, you can just simply say ASCII. Okay, that's just a keyword for MATLAB, and it loads the data file. And you have 51 data points by 2, so we can just examine how the data looks. Data 1 is the x value, and data 2 is the y value. So what I'm going to do is I'm going to store these x and y values in x and y variables, and let's try to examine how the data looks. So I'm going to say plot xy, and so since this is an experimental data, I will not try to plot it with connected lines. Okay, so that's how the data looks. Okay, and let me also add labels to it right away. X is distance, y is force. You feel free to use x and y for these x and y labels. Okay, so that's what I have my the experimental data. Okay, so what I'm going to do is now I'm going to hold on, and I'm now going to use polyfit. The way I have set up my polyfit is in the following format. Okay, so this is the code I wrote. I'm going to fit a polynomial of this form. Okay, and I'm going to get back the coefficients in this in the vector C, and I'm asking you to fit a polynomial of order 3, so n should be equal to, sorry, n equal to 2, of order 2, a quadratic. Okay, so what you're going to do is I'm going to say C mypolyfit xy, and n is going to be 2. Okay, and so it gives you those coefficients. What you are required to do is also show how your fit looks compared to the experimental data. So for doing that, what I'm going to do is I'm going to generate an anonymous function. We have seen this before. That's my anonymous function, and I'm going to plot this anonymous function at x f of x in the range, and the range was 0 to 5 angstroms, 5. Okay, 0 to 5, and I'm going to plot this with, say, the blue color. Okay, that's about it. So that's essentially what we need you to do for your assignment. And as always, please add labels. So you can have a legend which says experimental data, then fit. Okay, and I didn't pay much attention to where I wanted to place the label, but you know how to do that. Okay, this is all that is needed for assignment for this current problem. And just to show you the structure of my polyfit, please define the input variables and output variables. What I would encourage you to do is also to have the following check. that if in data, the number of data points is less than the order of polynomials, it is kind of stylish to have a check that to tell the user that the data fit will not be unique. Okay, and past this is the code that I want you to write. Thank you.